All right, you still have your Post-it notes?
Yes.
Get your Post-it notes out, get something out to write on, take notes on, do calculations on, scratch paper on, whatever. Anybody need scratch paper? All right, so first one here, we're talking about all elements and molecules are made up of atoms. Substances with the same atomic makeup have the same average mass. Ratio of masses of the same substances is independent of the size. Molecules with the same atomic makeup will have the same ratio of average atomic masses. For example, H2O2 ratio would be different than H2O due to that different chemical makeup. So here's your first question. Once you have your answer, put your answer out and let's talk about it. Can you guys read this okay? Do you need to come closer or? Kayden's going to give it a try.
No.
Why not? Huh?
I was doing something else.
I'm supposed to be doing AP Chem.
I was kind of related.
All right, let's see. No, the answer is B. All right, good job for those of you who got that. So 16 over 30 is going to give you 53%. Makes sense? Yes, good? Okay. All right. Pure substances are mixtures. Percent mass can be used to determine the composition of a substance. The percent mass can also be used to find the empirical formula. Remember, the empirical formula is the simplest formula of a substance, ratio between the moles of the substance. Quick steps to solve percent mass to moles. Mass to moles divide by the whole, the smallest, multiply by till whole. The molecular formula is also the actual formula of the substance sometimes. It's a whole number multiple of the empirical. Okay, so try this one. Compounds determined to contain 14 grams of nitrogen, 32 grams of oxygen. What's the empirical formula? Might need your periodic table for masses, possibly. I can do it in my head, but I have a lot of stuff memorized. All right, I'm going with C. The correct answer is C, 14. So 14 divided by 14 is 1. Oxygen is 32 divided by 16 would give us 2. So that would give us C for our answer. All right, impurities in a substance can change the percent comp. If more of a certain element is added from an impurity, then the percent mass of that element will increase and vice versa. When heating a hydrate, the substance is heated several times to make sure that that water is driven off. That's a common question on there. Then you're simply left with the pure substance of the excess water. Uh-huh, that's right, baby. You're gonna be singing that in the test, aren't you?
All I know is that we took a test one year and I got this one wrong.
Which one of these is not like the other? Which one of these different from the rest? All right, so A has the lowest percent by volume of oxygen, right? So if we had a low mass percent of oxygen in the sample, this would throw it off because it would scale these guys, this part up, and then that would lower this part. So if we had a low percent by mass of oxygen, that would be the cause. And the reason why Austin and I were singing this song is because this one doesn't have any oxygen and the rest of these do.
So like it was added to the glucose rate.
Yeah, so this goes in with the glucose, it gets mixed in there. That's going to drive up the value of your carbon and hydrogen, and it's going to reduce the value of your oxygen. All right, mole calculations, grams times, if we want to, you can go this way with it. You're going to divide by molar mass to get to moles and multiply by molar mass to get to grams, and then you can get to Avogadro's number like this, okay? If you want to see that in terms of like atoms and grams and that sort of thing. All right. You can use some scratch paper, just don't use a calculator. You need any takers on this one? Three C's and a B. Let's see. 3 C's win. Good job. All right, electrons occupy orbitals whose energy level depends on the nuclear charge and average distance to the nucleus. Electron configurations and orbital diagrams indicate the arrangement of the lowest energy, most stable form. Electrons occupy the lowest available energy level. When you were in regular chem, I made you like walk in and you had to sit in a certain, way and everything. Okay, maximum of 2 electrons may occupy each energy level. Must have opposite spins. That was your plus minus. Sometimes you'll see it as plus 1/2, minus 1/2. Other times you'll see it as up-down arrows when you have an orbital diagram. In orbitals of equal energy, electrons maximize parallel unpaired spins. Which of the following electron configuration and orbital diagram is properly represented? All right, let's look and see. Indeed, C is the correct answer. The issue with this one is that this guy has been promoted up to here. So unless this has been energized or something, which they didn't say anything about that, this would not be the appropriate answer. This guy, these would need to be in separate. We don't double up until we have these all filled with one. And then this guy over here, the 3p comes before the 4s. So this needs to be flipped, and you would need to have your electrons separate like this one. Okay? All right, ionization energy. First, ionization energy indicates the strength of the Coulombic attraction of the outermost energy or electron, and how and that would be the easiest electron to remove. The first energy level then increases as you go across the periodic table, it decreases as you go down. And it also generally increases as the proton number increases in the same energy level, and it decreases as electron in the higher energy level because of increased shielding. I'm sorry, decreases. Increased shielding, electrons are further from the nucleus. Okay, I always talk about this in terms of, like, you know, you're getting further away from mom and dad when you're out here, so it's easier for you to get away. Okay, they don't have as much control over you as you get further away. All right, so try to arrange these in order of increasing first ionization energies. Try to get me a cotton t-shirt. Don't get this like out like this thing. Don't get this thing. Get cotton t-shirts, by the way. A. Rose says A. She's going to say A just because she's going along with everybody else. And A is indeed the correct answer. Okay, magnesium, carbon, nitrogen, fluorine. Okay, as we get, these are all in the same row. No, they're not. Magnesium's not in the same row with those guys. Magnesium's down one row. Carbon, nitrogen, and fluorine are all in the same row. But as we move across, we're getting more protons here. So it's going to be harder and harder to pull that electron away. Okay. Photoelectric effect then. It's going to use high energy photon. It's going to excite those electrons. Okay, kinetic energy of the ejected electrons then equals the binding energy, or that Coulombic attraction. Remember, Coulombic attraction deals with distance and force. So as things come closer together, that force increases. As the distance increases, the force is going to decrease. Direct measurement of the energy and the number of each electron. Lower energy levels have higher binding energy because they're closer to the nucleus. They have more control from that nucleus. Signal size proportional to the number of electrons in the energy level, and the elements with more protons have a stronger Coulombic attraction, higher binding energy when they're closest to the nucleus. All right, so which element would be represented by this? This is line 1, 2, 3, 4. And this is line 6. Oh, you want to answer E?
Yeah.
Okay, I'll put you in for E then.
That one's weird.
Yeah, it is. Why is it weird?
Because it shows 4 electrons.
No, it shows 4 lines. And you know when you're closest in, how many electrons is that going to be?
I'd like to change that.
Would you? Anybody else? That's why I said 4 lines. I did not say 4 electrons when I counted those for you.
Oh.
Two, 4. Well, how is that now?
Because there's 6 lines in the third one, so it'd be 1, 2, 3 spots full.
3, 4, 5, 6, 7. Oh, 7. Lord, I can't count today, y'all. Okay, well, then we're right. Did you say C? Did you correct it to C?
I said B. I wasn't thinking.
Yeah, well, I obviously wasn't either because I got it wrong too. But I still saw that that was 4 lines but 2 electrons. So at least I got that far on it. All right, here we go. Second and subsequent and ionization energies increase because your Coulombic attraction is going to increase. You've got more protons pulling on those electrons. Okay, so you're going to get a large jump in, and especially when you go from like here to here, when you hit that level, because you're getting closer in because that distance is decreasing. Okay, so keep that in mind. See how we do on this one. Oh, there's a big jump there. Look at that. See that big jump? So count how many elements you had before you got to that big jump. How many you got? 1, 2, 3, 4. That means that this is going to have a +4 charge on it. +4 charge. Is the only one with the +4 charge, right? This would be a -3. It could have a -4 charge too. I mean, either way, but it's gonna gain or lose, you know. So it's gonna have a 4 there.
No, I was thinking 4.
Now, if your big jump would have occurred here, then it wouldn't have been carbon. It would have been this guy.
Well,
If your big jump would have occurred between these two, then it would have been beryllium. If that big jump would have occurred between these two, then it would have been lithium. And if you would have had a sixth one here and the big jump would have occurred between those two, then that would have been phosphorus.
No.
All right. First ionization energy decreases from beryllium to boron, magnesium to aluminum. Electrons in the 2p or 3p are shielded by the 2s and 3s2 electrons, decreasing coulombic charge despite additional protons in the nucleus. So that's why there's this little hiccup down here. I don't know. Oh, I can't do that. It's going to make that bigger. Okay. There's also a little bit of a kickback right here because you're doubling up electrons there. Okay. So this is, you've got 1, 2, 3, and then they're doubling up. So you're going to get a little bit of a repulsion there as well. Okay. So that's what that's talking about. All right, try this guy. Phosphorus is here, sulfur's here. Oh. Well, did it not give us our answer? Doesn't look like it did. Oh, there it is. A. I guess it did. So sulfur has one more proton than phosphorus. It has a higher effective nuclear charge. But due to the 3p4 configuration, remember it's going to kick back just a little bit. So if we go back here, okay, we got that little bit of a kickback there where those electrons double up. Okay, that's why A is going to be the answer there. All right, let's try the next one. We got Coulomb's law. We talked about that guy. We actually did, I think, a POGL at some point with it. As we move across, our atomic radius is going to decrease, but ionization and energy and electronegativity is going to increase because we're increasing that effective nuclear charge. Here, we're going to increase the atomic radius because we're moving down. We're adding levels. We're getting further away from the nucleus. So ionization energy and electronegativity are going to decrease because we are increasing the shielding, and we're also increasing the distance from that nucleus. Okay, we talked about Coulomb's law. Okay, we've got the distance makes a big difference. We've got those two forces that we're going to multiply together, but that distance makes a difference. Okay, let's see if you can figure out this guy. We did something similar to this in our review the past few days. You've seen one very similar to this recently. We got several A's and no D. So yes, this is correct. Okay, we're moving from sodium to magnesium. So sodium, this guy's next door. So remember, our radius is going to get smaller because we've increased our effective nuclear charge. So this value should go down here. Okay, so it's going to get rid of B and D. So that leaves us between these two. The ionization energy, we've increased that nuclear charge. We've also drawn it in tighter. So based on that, this value is going to be higher than this value. Okay? Chemical reactivity then, nonmetals have higher electronegativities than metals, causes the formation of these ionic solids. Compounds can be formed between metals or molecular, so they form molecules. Typically gases or liquids or volatile solids at room temperature. Elements in the third period and below can accommodate a larger number of bonds because remember they can have expanded octets. First element in a group, the uppermost element of a group is going to form those pi bonds more easily, and the second row is going to form, a row would be with the nonmetals. It's going to account for those stronger bonds in the molecules. Major factor in determining the structure of compounds formed in these elements are how these elements are going to bond, and then the elements in 3 through 6 tend to form only single bonds. Reactivity tends to increase as you go down a group of metals and up a group for nonmetals. Okay, of the elements below, blank reacts the most quickly with water. I gotta write you a pass. I got an A, I got 2 A's. What else do I got? Anybody else gonna chime in? It is Friday, y'all. There you go, sir. All right. So as we move down, remember what this said. As you move down the periodic table, reactivities for metals is going to go up. Anybody want to change their answer from A?
B says it goes down.
Yep, reactivity tends to increase as you go down a group for metals. So is there something south of sodium listed here? What is it?
Cesium.
Cesium CS, yes. Yep. So cesium is the correct answer. All right. Group 1 metals are more reactive than group 2 metals. Reactivity increases again as you go down when we're talking about metals. Metals on the left form basic oxides. So you're going to form sodium oxide plus water is going to give you sodium hydroxide. Non-metals on the right form acidic oxides. So they're going to form acids. Metals in the middle, like aluminum and gallium, can be amphoteric. So amphoteric means that they can form either acids or they can form bases. Okay, it's like water is amphoteric. It can form either an acid or a base depending on its condition. Silicon dioxide can be a ceramic. Then tin oxide, tin 2 oxide, it would be tin 4 oxide, may be as well since both are in the same group. Okay, and where's the question? There it is. Is that the question? Yeah. Yes. Alkali metals. You guys know that. We've talked about that.
Yeah, I'm mixing them up. The earth metals is the second row, right?
Correct.
What's the
2 words, second row. What? Those would be the ones down with uranium. Down at the very, very bottom. We're never going to deal with those in this course. All right. So, Bohr model here, developed by Schrodinger and his cat, probably. Well, if his cat's still alive, I don't know. And
like alive and not alive.
yeah. If it is out of a box, you just don't know. Now, I would think that you would know because it'd probably be like clawing itself to get out, but whatever.
It may have helped, it may not.
Yeah. So, position of the electrons, we know it's probably here. So, yeah. The thing is that, like, you know, they talk about all this fancy stuff and they're like, well, you know, we can say with 90% probability that it's in this, just say that it's in this shell and be done with it, okay? Makes life easier. But, you know, they got to get all technical on it. Well, technically, yeah, okay. All right, so the patterns then for this, the graph shows that we're seeing this ionization, okay, as we move across. Ionization energy is increasing. Again, this is getting bumped here because the distance is greater. It's getting bumped over here because we're doubling up. And, oh, look, another one of these. Let's see if you can redeem yourself on some of this, on this one. Identify the element. We'll do this question first. Where's my big jump? Yep, B is the correct answer. Okay, which ionization energies correspond to the electrons that would account for the peak in the photoelectron spectrum of the elements that has the lowest values? So they're talking about these, which one of these would correspond to these low values here? As the lowest values. Would it be the first electron, the second electron, this first 4? Would it just be these last 2? Yes, correct. A is correct. Good job. Huh? Did you ask a question?
No.
Okay. It's hard to hear with the mask on. Well, I know you're quiet and you have a mask on. So it's like this double, like.
I'm always quiet after that.
All right. Mass spec shows that elements have isotopes. Has contradicted Dalton's early model of the atom, which stated that all atoms are identical. Okay, we've got 3 bromine Br2 and 2 bromine isotopes are shown in this diagram. The average atomic masses of the elements can be estimated from this information. Okay. So both zirconium and niobium have similar atomic average masses. above the mass spectrum of a sample that was believed to have been both, which of the following statements would be the best explanation for deciding that the sample contained only zirconium? All right, the answer is D. Good job, Kittle. Okay, NB has only one stable isotope with a mass of 93. While all the statements are true, only answer D would indicate that NB is missing from the sample. Okay, so they're asking only ZR. All right. So this is radiation. IR radiation, UV, so infrared, UV, and X-ray. Okay. So infrared radiation detects different types of bonds by analyzing molecular vibrations. UV and X-ray radiation causes electron transition. So they're going to move from one place to the next. Okay. So which one of the following contains a transition paired correctly with an area of high absorption in the electron spectrum? Would microwaves cause a transition? Would infrared cause a transition? Would infrared cause rotation? Or would infrared cause vibration? We talked about this in pre-AP or AP? I know we talked about this.
We did.
Yeah.
Oh, a while ago.
Because I talked to you about how to remember microwaves, right? What did I say about microwaves? What happens in the microwave? It spins things around, right? So that's rotation. So the microwave is always going to be rotation. So infrared is vibration. It's going to cause it to vibrate. But the microwaves, you've got the turntable in there. That's how I told you guys to remember that. The turntable in that microwave is going to turn it. Okay, this is Beer-Lambert. So this is when we're dealing with absorbance, molecular absorptivity. We've got path length, concentration here. Okay. So we've got our absorbance. So this is our big A. Remember that when we pass things through these, our material in here is going to absorb stuff. The more concentrated that material is, if it absorbs light, the less light's going to get through. Okay. And we were able to detect that light on the other side. Okay. So they measured the absorbance to be 0.4. So they measured it right here. What would the concentration of that material end up being? B is correct. Good job. You just have to follow the graph and figure that one out. So that's not too bad. Law of conservation of mass. Okay, this is common with the particle diagrams. You can't create new stuff over here. It's a sealed container. So the picture above is a representation of H2O2 in a sealed container. So we can't get any extra stuff in or out. Okay? Which of the following pictures would best represent the products of that? Why would oxygen come out? Why would it separate here? This wouldn't be H2O, this would be HO2, so that guy's out. This we lost oxygen on, so he's out. This one, again, we don't have HO2, we have H2O, so this guy is the one that would be left. All right, so that's where we'll pick up next is 118. So keep working on your videos, keep working on your,
Yeah. What am I doing? Doing something wrong. I was like, fix that. But then, did I do this one wrong?
well then, this is in a 1:5 ratio, right? So
What's in a 1:5 ratio?
for every one of these, you got 5 of these.
Okay.
So this, to get down to here, you've got to multiply this times 5, and that'll give you moles of Fe.
So how do we know it's in the 1:5? Oh.
Well, if you would have gone through and done this
Oh, we're supposed
stuff,
to do that first.
yeah, then, and I have all the answer keys to all of this stuff on there, then you would have come upon that. Okay?
Yeah, we started off our match winning like 3 games, and then they switched it up, and like we never had to like switch up our game before because like it just worked. So that was fun. Because you could beat the people that played number 1, and they weren't even going to be here for subsectionals or sectionals. And she still let them play number 1 because they were seniors. I'm like, first of all, we're better.
Yeah.
And they're not even going to be here.
Right.
So what does it matter?
No, it's just.
Because then that really messed with us when like
Yeah.
we have to try and like now like be able to like switch back between things and we
Well,
have
and
no
it's
practice
like,
in
it's
it.
not like you can, like, you two need to play. I mean, it's like a team thing.
Oh, and she also would switch us between doubles and singles during the season. Literally, we played number 2 doubles, and then one match, Middleton, she's like, oh, singles. I'm like, okay, thank you. Like, this makes no sense.